Okay, so I'm Maarten De Strycker from BCCA in Belgium, and in the next 10 minutes I will talk to you about the building airtightness data that we collected for the Flemish building stock. So first, to give some context about airtightness testing in the Flanders region, just a little context about the data that we are talking about. So in the energy prestation regulation in Flanders, you have two options, or you work with the default value of 12 cubic meter per hour per square meter heat loss area if you don't perform a test, but if the builder performs a test, then he can count on a measured and normally better value than this default value of 12. So we work with the leakage rate at 50 Pascal divided by the heat loss area in Belgium. So, and if a builder wants to use test results, then the test should be done within a quality framework in the Flemish region. And this started on the 1st of January in 2015. So we're talking for about 6 years now. So we have data for 6 years I can present today. So we have a quality framework that is organized by BCCA, and there's a separate technical reference document in Belgium. This is TSTSP 713, and this is referring to the European standard with some additional specifications typically for the Belgian system. So before a tester can perform an airtightness test, he can follow a theoretical course. It's optional, but he has to pass a theoretical exam in which he has to solve a 50 multiple choice question, and he has also to pass a practical exam, which consists of doing full test on site and making a measurement report of this test, and this takes about 3 hours. And after that, he is subject, or she is subject to random inspections. This means that BCCA is going on 10% of the measurements that are done on site, and then we verify the correctness and the reliability of the measurements that are done. And additionally, afterwards, 10% of the test reports are also checked by us to verify the correctness and the completeness of the test reports. This happens only in the northern part, in Flanders, in Belgium, and the other regions, Walloon and Brussels region, do not have a quality framework yet. So we do not have a systematic registration of test results. So what I will present is only about Flanders. Then what is in our database? Well, the tester has to enter some information in our database about the test that he is going to perform. So of course we need some administrative data like the address where the building is. What is the main destination of the building? Is it residential? Is it a building? Is it a school, for example? And then for multifamily buildings, it can be tested as a whole, or each apartment can be tested individually, and this is also to be indicated in the database. For the inspection on site, we need the planning and timing of the test, so we can send an auditor to the building to check the test that is done, and then he has to report the leakage rate and the heat loss area in square meter or the internal volume. So only one of the two is mandatory to report. So we do not have for all buildings both data. And then he has, of course, to give the full test report, which is a PDF, and some pictures about the test that was performed. So we know that there was really a test performed at this building. Afterwards, they have to send an SMS with the leakage rate to facilitate these random inspections we do on site and to check the reliability of their result. What is maybe missing in our database is that we do not have any details about the sources of the leakages. So we do not have any details about that. And we have, statistics available since 2015, although 2015 might be a little bit less reliable because of the learning curve we had in that year. And you need to know that we are having about between 3,000 and 7,000 measurements registered each year in our database. So what is the main destination of the tested buildings? About 95% is residential and 85% are individual dwellings and flats that are tested. Here you see that there is no big evolution over the years. So for the years we have data, I set out what is the building type that is tested. So there is no big evolution over time in the type of buildings that are registered in our database. If we take a look at the lowercase p50 value, then we see that for about 1 to 3% we cannot calculate this value as the area is missing, and about 25% has a leakage rate lower than 2 cubic meter per hour per square meter heat loss, and about 40% is between 2 and 4, and the rest has a higher leakage rate. So here you see no big evolutions from this graph, and this becomes even more clear if we take a look at the average lowercase p50 value, where we cannot really see a big evolution towards a better air tightness of Flemish buildings. Another data that we have is the distribution of this p50. Here I present the data for 2020. So here we do not see big, unexpected results. There is not tested toward a certain result, such as, for example, 2 cubic meter per hour per square meter. And so from this distribution, as it is, as we expect, we cannot presume that there is fraud on a big scale in doing these air tightness tests. And also what we need to know is that the EP regulation doesn't impose any limit to the air tightness. Of course, the better the air tightness of the building is, the better the energy performance will be. But there's only a limit to the overall energy performance of the building, and not to separate details like, for example, the air tightness. So if you have a building that is lower performing on air tightness, you can maybe compensate by putting more PV panels on it or using a higher efficient heat pump in the building. Next slide is the N50, so the air changes for this parameter. We do not, for about 60%, we cannot calculate because the internal volume of the building is missing. And if we take a closer look at a subset where with the known internal volume, so where we can really calculate the N50 value, then we see maybe some more fluctuations, as this subset contains about 1,000 to 3,000 tests for each year. So we see more fluctuations, but again, no clear evolution towards better air tightness. This becomes maybe more clear if we take a look at the average and 50 value, which stays at about 2 air changes per hour. So no clear evolution, and that is my conclusion. So we have a database that contains mostly data for residential buildings and mostly individual residential units, but we do not see a clear evolution towards better air tightness in Flanders over the last 6 years, as since 2015 the average lowercase p50 value remains more or less the same, and we lack details about the sources of the leakages. If you want more information, we have a website, unfortunately only available in Dutch and French. I give you the link to the French website, which might be already a little bit more international than the Dutch one, but you can easily switch to the Dutch one as well. So this was my presentation. I'm open for further questions now.